Hey, this is our next lecture on solving logarithmic equations. Hopefully, while I was gone, the properties of expanding and contracting went well because we'll be using a little bit of those today. So when we're solving log and exponential equations, first thing we want to do is check to see if there are any logarithms that you can take out of the problem, evaluate and replace. For example, we know that log base 2 of 8 could be replaced with 3. You could either say, hey, what power of 2 is equal to 8? Or you could look at the property like this, 2 cubed, and when a log and the input of is an exponential with the same base, the output is the power. If the equation is written in exponential form, then rewrite it in logarithmic form. That's the most important. Remember, inverses we're going to rewrite into the inverse form, just like we've done all different equations. When we have a quadratic, we square root both sides and we turn a quadratic into a square root function. Okay, and vice versa. If an equation is written in logarithmic form to solve it, we're going to use the inverse and we're going to rewrite it in exponential form. And then we're going to solve the remaining equation. Remember, when you use an inverse, you are going to get the variable by itself. We've done that ever since grade school. And then we're going to check our answer using your calculator store function. Okay, number one. The first thing that I'm going to do is notice that I have a exponential and the variable is up in the power. So I know I'm going to have to use the inverse, which is the log. But before I can do that, just like the log, we have to get the exponential base and power alone. Very similar when we did radicals. You have to isolate the radical by itself. Both these logs and exponentials, you have to isolate the base and the input by itself. So the base of this exponential is e, the input is x, and now the output is 55. Okay, now I'm going to change this into a logarithmic function, and I'm going to say the natural log, since remember this is one of those hidden bases. It is log base e, but we write it as natural log, and the output to the input equals x. And there's my answer. Now all I need to do is go to my calculator and I'm going to plug in natural log of 55, hit enter. And if I wanted a estimation, I could get 4.007. If we wanted to check our answer, we could definitely go and say, let's see, second ln or natural log. There's your button. And I could put in natural log of 55. And then I could go down plus 5. And you could hit the enter button and you would notice you get 60. That's what I output on number one. Okay, number two, here's another exponential. Again, this is more about isolating in the beginning and getting used to doing that than anything else. I have one base, so all I'm going to do is isolate that base, and then I'm going to divide by 2. Don't get a decimal. Don't write 7.2 there. We don't use fractions. I mean, decimals like that. Unless we're dealing with money or something. Okay, so now I'm all isolated. I don't even need these parentheses anymore because I have isolated it all by itself. And now I'm ready to write the log. So this time I have a log base 3, and the output of the exponential is 15 halves, and that's going to equal the input of the exponential, which is the output of my log. And now all I just need to do is isolate the variable by itself. Remember, log base 3 of 15 halves is just a number that our calculator can handle. It'd be like saying square root of 3021. We wouldn't know what it is, but I'm going to hold off putting it in my calculator until I get x by itself. So I'm going to carry this up here, and I'm going to write log base 3, 15 halves is equal to minus 5. I'm going to add my 5. Now remember, this log base 3 of 15 halves is a number by itself, so you would not want to add 5 to that 15 halves. That would be and then I'm going to divide everything by 2. And that's my answer that you would probably show up on an ACT question. or a 10 ready question, but if we wanted an estimation of that for a word problem, then this is how we would put it in our calculator. So you just kind of step by step that. Let me do a side by side view. I'm going to go to math, and the up arrow key is a little bit easier to get to your log base change. And I'm put log base 3, and then I'm going to come over and put 15 divided by 2. And then what I would do, let me get over there, is I would hit enter. Okay, you could hit, and then I'm just going to go through the sequence. And if I hit +5, it's going to pull that previous answer with all the decimals. And I'm going to add 5, and now I'm going to hit divide by 2. So as long as I'm doing that step by step, it'll pull that all those decimal places with it. So then I'm left with 3.417. Let's round to the nearest thousand. Okay. The next problem. Get this off the screen. Here we go. Next problem. Now, anytime you have an exponential and you have multiple, first of all, that it's a trinomial and they have the same base, you're going to have to get used to looking that this is probably going to be a quadratic. And we've encountered these, but it's been a while. So remember, I can write e to the x as e to the x raised to the 2, and that's the same thing as e to the 2x minus 3 times, again, I have e to the x plus 2. Now, if we remember, if we want to go ahead and just replace e to the x with x, or let's do u, doesn't matter which variable you use, but over to the side, I know u is really e to the x. And I'm just going to factor now. U minus 2 times u minus 1 equal to 0. Get u is equal to 2, and u is equal to 1. And this is kind of where we can make a mistake because we're so used to dealing with polynomials, we think we're done. Don't forget u is really e to the x. So as I'm finishing this off, I've got to put e to the x back. Notice this one's easy. It's a property. Anything raised to the 0 is 1. And this one I have to convert to a log. So I'm going to say the natural log, the output's the input. And I could either keep that as natural log of 2. If I wanted for some reason, a decimal estimation, I could put 0.69. Let's see the other one, 3. Okay, but if you had a multiple choice test or a ACT question, it would be left in log formation, just like when we work with pi. Okay, next is, so we did 3 of the exponentials. Now we're going to look at 3 logs. Okay, number 4 is just a log problem, right? Do I have the log, its base, and its input isolated by itself? And the answer would be no. Okay, so I have to get rid of the 2. Now there's 2 ways you can do this. I could bring the 2 up. We learned about that property, right? I can, if there's something multiplying in front of the log, I can use the power property, and I can bring this up, and I could have squared the whole thing. However, I would not do that unless if it seemed absolutely necessary, like there was another x on the other side. But notice if I divide this 2 off from both sides, 4 is nicely evenly divisible by 2. So that using your power like that and bringing it up sometimes can make it a harder problem. You're going to end up with a quadratic that way. And sometimes it's necessary. So it kind of just is experience and working the problem. But I can tell you this, if there is a number multiplying by the log, um, you try to divide it if the right side, especially if it evenly divides. Okay, my next problem would be converting it into an exponential. So log base 3, the output is 2, comes the input of the exponential, and then the input of the log is 3x, which is the output of the exponential, and then I have a nice easy problem. Just like any inverse, square and a square root, easy process. So x equals 3. Don't forget the domain of a log is restricted, it has to be greater than 0, right? So if I plug 3 in here, I get log base 3 of 9, which is acceptable. It's within the domain. Okay. Number 5, look at this big long log property. So notice I have 3 logs, so I'm going to have to do some contracting to get this down to 1 log so that I can solve it. So let's start with the left side over here. I know if I have logs at the same base, then we have that difference property where I can divide, or the quotient property where I can divide these 2 logs. And I'm just dividing the input part. Remember, the log wouldn't carry the top and bottom. Then I'd go from 2 logs to 2 logs. It's not going to really help me. The whole point of condensing is to reduce your amount of logs. And just like we were doing our properties, we are just going to rewrite everything on every step. Now notice I can use my one-to-one property. 1 log on the left side, 1 log on the right, same base. This makes it a lot easier moving forward. So problem with these was how I said this is probably our hardest chapter, or our least successful one. It's because a lot of times, I'm going to multiply by 5, there's so many different ways to work these, and they just take experience and practice. So I always said, do your homework timely, practice. I know some of the problems are redundant, but it'll pay off in the end. Divide by 3x, divide by 7, x is equal to 2. Now I want to make sure that I plug this 2 in to all the x's of the logs, and I don't get a negative number as an input. So 2 times 2 is 4. If I put the 2 up here, that's good. The 5 didn't have a variable, and if I plug the 2 in here, I get 6, and then plus 4 is 20. So this one checks out of us as a solution. If I had plugged that 2 in somewhere and I'd have gotten a log of a negative input, then it would have been no solution. Okay, my last one, I'm going to condense these logs together. Remember, I only want one log, one exponential, unless if I have that kind of different scenario. I had 2 exponentials, but it was a trinomial. Anytime I have exponentials and they're trinomials, I'm always thinking factoring. Okay, so back to this log, I've condensed addition with multiplication using the product property of logs. And now I'm ready to convert. This is a log with a hidden base of 10. The input is the output of the log. The log is outputting 2. And the output of the exponential is what the log is input, which is 5x. I'm just going to go ahead and multiply that. 5x squared minus 5x. Speaking of a quadratic trinomial, here we go. I'm going to subtract this 100 over to the right side because 10 squared is 100. I also know that this is pretty nice because everything's divisible by 5. Let's make our life easy by dividing everything by 5. And 20 times 5 is 100. I have a nice factoring problem. If it wasn't factorable, we would have to use the quadratic formula. So x minus 5 times plus 4. And I'm going to set those equal to 0. And solve. So just did that one step. Now I'm going to go up and make sure that both of these are solutions. If I plug in 5 into the log, I get log of 25. That's acceptable. If I put a 5 up here, I get 5 minus 1 is 4. So solution. Now I'm going to try the negative 4. 5 times negative 4 is negative 20. You cannot take the log of a negative number. So this one is outside the domain and is not a solution. And when we gained a solution that doesn't work, I think we usually call that extraneous, just to keep our definitions up in case if we run into that somewhere. So your homework today is going to be working out of the book, and then we'll work some in Delta Math. And then on Thursday, we will pick up with, hopefully we'll be able to knock off all the solving, and then we'll apply it to some word problems and some equations using logs and exponentials. See you tomorrow.